First of all, because this topic is very relevant and very innovative, and it's good to know what's happening. And the second one is also because it's giving us the private sector perspective. Because obviously, as I'm involved in the university, I can speak more about projects and initiatives related to the academia, while on the other side, Sanghee can enrich what we are seeing, proposing us also the point of view of the private sector. So thank you so much, Sanghee, for accepting again. This is the second year Sanghee is presenting to my student, for accepting again to tell us what you are doing. And now at this point, I will give you the floor. So I will mute myself and I will let you speak.
Okay, thank you so much, Maria. Thank you for your kind introduction. Hello, everybody. My name is Sanghee Shin. As introduced by Professor Maria, I am a CEO and then the president of Gaia3D, a geospatial company here in Korea. I established my company in 2000, so my company is 25 years old now. So today I'll talk about the urban digital twins here in Korea, and then the many of the projects introduced in this talk is carried out by my company, Gaia3D. Okay. So what is digital twins? Actually, the term digital twin itself also represents the concept itself, also explains the meaning of digital twin itself. Actually, digital twin is twinning of real world in a digital world to a digital world or a virtual world. Actually, you can see the conceptual diagram of the digital twins that was proposed by Professor Michael Greaves in 2001. And now you can see the concept of the digital twins. Actually, we can get the data from real space, and then we can reconstruct the virtual space using that kind of data. And then in a virtual space or a digital space, we can simulate many things. And then we can get the information, and we'll feedback that kind of information to the real space. By doing this, we can reduce the trial error, and also we can reduce the cost. Also, we can repeat the many kind of simulations repeatedly and repeatedly. Yeah. So actually, digital twin is nowadays applied to the many industries. And then according to the one paper, around 2/3 of digital twins market is in manufacturing industries, including automobile companies, industries, and then around 20% occupied by smart cities, and then around 15% for the healthcare. So today I will talk about the urban digital twins. Actually, from now on, I would like to introduce the South Korean government digital twin project, national digital twin project, very briefly. In 2017, so around 8 years ago, National Research Institute published one report, policy report, and then that they proposed that South Korean government should invest in a digital twin for the promoting of the national GIS. In Korea, central government set up the national GIS basic plan every 5 years. So in 2018, Ministry of Land and Infrastructure and Transportation included the digital twin concept to their 6th national GIS basic plan. As a result of that basic plan, South Korean government showed this kind of very ambitious plan to the citizens of South Korea. And at the time, they said that this is a GeoCPS, and then sometimes they said digital twin. But in my opinion, the concept itself is very similar to the GeoCPS and then the digital twin as well. So we can get the data from real world, and then we will mirror the real world to the digital or virtual space, and we will carry out many kinds of simulations, and then we will feed back that kind of simulation data to the real world to solve the urban problems. So in 2019, South Korean government started to carry out the pilot project to implement a real digital twin project for solving the urban problems. So they invited bidding from many companies, and then they started the pilot project like this. So at that time, they believed that the digital twin is a kind of the people participation platform. So they have to build GIS and also building information modeling data and the 3D GIS. At the same time, they would like to get the IoT data, CCTV data, and then on top of that, they would like to implement some kind of big data analysis, visualizations, and then the other geostatistics. So that was a basic concept of the pilot project of the National Digital Twin in Korea. And then as a result of that pilot project, now South Korean government started to invest huge money to carry out the National Digital Twin project together with the local government. So in 2022, South Korean central government funded lots of money to solve many urban problems. And then also they continue to invest much money to solve the urban problems in many areas. Those are the local government. And then 2 years back, South Korean government set up a new 7th National GIS basic plan. Also, they, according to their 7th NGIS basic plan, they will continue to invest and the huge amount of money. They said that they would like to invest around $3 billion US for the next 5 years. So they believe that National Digital Twin could solve many kinds of land problems and urban problems. So they are very, very confident. So another big player in terms of the South Korean urban digital twin is the Seoul Metropolitan Government. Actually, Seoul Metropolitan Government is a local government. But due to the amount of the economic power, Seoul Metropolitan Government has their own track to implement urban digital twins for their own Seoul citizens. So they started the very similar years in 2019, and then in 2019, they captured the whole Seoul city in three-dimensional way, and then from 2020 to 2021, they started the urban spatial information connection, and then the 2022, they started the urban analysis simulation, and then nowadays they are at the 4th step, so-called collaborative digital twin. And then they articulate their digital twin under the brand of the SMAP. So this is the SMAP concept. So, and then Seoul Metropolitan Government believe that the SMAP, virtual Seoul or digital twin Seoul, will be the key to the smart city of Seoul. And then actually, Seoul Metropolitan Government is just a local government, but they have really lots of geospatial data. Also, they published lots of data for the citizens. In my opinion, they have too much data, too many data, and then sometimes we are in the middle of the data flood because the Seoul Metropolitan Government publish and open too many data. Anyway, this is a SMAP data layer. Another great player in South Korea is the LH Corp. LH Corp is a state-owned public company. Their mission is providing a land and a house to the South Korean citizens. So they have more than 8,000 employees, and then it's a very, very huge company. And then because they have to provide a house, or they have to provide land, and they have to develop a new town, this digital twin is very, very essential for their mission. So around 4 or 5 years ago, they started to develop their own LH digital twins, and they set up their own strategy. So the first one is standard. They want to develop their own digital twins complying with the international standard like OGC or Building Smart and ISO or W3C. And then their strategy is that employing a cutting-edge technology like Geo IoT or AI, and then the AR, VR, and other things. And their third strategy is like this. They believe digital twin should be a collaboration platform. So many stakeholders should involve in this platform, and they can easily communicate the problems and plans and other materials with other stakeholders. So as you know, urban development is really, really complicated, and then it took really long years. So they believe that the communication is one of the key success factors for the urban digital twin. And then very interestingly, they implemented their LH urban digital twin using open source. So they used lots of open source. Also, they opened their source code to through the GitHub. So from now on, I would like to showcase some of real digital twin use cases, mainly carried out by my company. Actually, at first, I would like to just a moment. At first, I would like to introduce my company's open source-based digital twin platform called Gaia3D. Gaia3D is a web-based digital twin platform that can manage and visualize various kinds of spatial data, simulation data, and modeling results. If you visit my company's GitHub page, you can see all the source code. Also, you can download our program, and you can use that. So one of the key components of Gaia3D is that Gaia3D tiler. Let's imagine that you have lots of 3D data and 2-dimensional data, and you want to publish and you want to service those data through the web for your digital twins. In that case, we usually use the standard called OGC 3D tiles. So you have to convert your 2-dimensional data or 3-dimensional data to OGC 3D tiles. But there is very few tools are available to convert those kind of data to OGC 3D tiles. So I bravely opened the Gaia3D tiler to the public as open source. So now you can download our Gaia3D tiler, and you can convert your many kinds of 2-dimensional or 3-dimensional geospatial data into OGC 3D tiles. Our Gaia3D supports 3D Studio files, OBJ, FBX, and then the building information modeling standard IFC 2x4. Also, we support the CityGML, indoor GML. Also, we support the point cloud, include large. Also, we support the shapefile, GeoPackage, and then the GeoTIFF and others. Also, you can you can convert the coordinate system during the OGC 3D tiles making process. So I believe Gaia3D tiler is a very, very nice tool. So please download and then use this one for building your own project for the digital twins. Actually, this is very, very popular nowadays. Now you can see the GitHub page. So from now on, I would like to showcase the real project. This is how we integrate the building information modeling data and then the 3D GIS on web browsers. Actually, this project is for the Sejong research base in Antarctica areas. So now you can see the whole buildings in Antarctica. And then this is the main building. Our scientists, engineers live here. And then all this layout is in building information modeling data. So we can see that two-dimensional or three-dimensional layouts like this. Also, by sliding out each floor like this, we can see the indoor space here like this. And the right side, you can see the list of the facilities. Actually, this is. So now, right side now, you can see the list of facilities. So our scientists and our engineers use this kind of menu to manage the facilities. Actually, they are living in the very, very harsh conditions. So it's very, very crucial to manage all the facilities in a proper way to survive out there under the minus 30 degrees. Also, all the information is linked with the attribute. So by clicking the object, attribute information will be popped up like this. And then they can upload their activities, and then they can change the attributes and other things. So also changing the opacity of the outside world, we can see the indoor space. Also, in Sejong Research Base, there are three power generators. They generate electricity. At the same time, they provide the heating to the scientists and the engineers. Without a kind of power generator, they will die soon. So that's why they have three power generators in the Antarctica scientific base. This is just for visualizations, how we can use the building information modeling data for the indoor navigations. So like this. So now you can see the meeting room, and then now you can see the dormitories. Also cooking room. Yes. And another case is that from LH Urban Digital Twins, as I already mentioned, the main mission of the LH Corp is that providing a house and providing land to the Korean citizens. But many of you are quite familiar with zoning. Actually, urban development is all about zoning, and that means that urban development is all about the regulations. So LH should be compliant with many regulations. So there are two major regulations in terms of the building coverage ratio, also floor area ratio. So any kind, all kinds of the urban development should be compliant with that kind of things. So using urban digital twins, we can simulate the building coverage ratios or floor area ratios by changing the number of floors from 15s, 16s, 17s, and then the building coverage ratio, and then the floor area ratio will be calculated automatically like this. And then our designer and then our planner will check whether their planning is compliant with the current regulations. And the noise simulation, this will show you the noise simulations. In South Korea, there is a regulations that in daytime, the noise level should not exceed the 65 decibel, and in night time, noise level should not exceed 55 decibels. So if the noise level exceeds that kind of things, and then the proposal will be rejected by the government. So we can simulate the noise like this. Left side is a very small noise barrier. Right side, you can see that if we put the noise barrier around the apartment, and then the green and blue means that area is compliant with the regulations. So noise barrier. We can detect the noise weather very beautifully. And then our designers and then our planners will propose this kind of new town development project to the government, and then the government will be satisfied with this kind of compliance. Also, microclimate is also very important to the citizens. So we have to check the microclimate before and after constructions. So left side, there is no building constructions, and the right side, now you can see the after construction apartment. So left side, there is no high buildings, so the wind itself is very straightforward, but the right side, now you can see that after construction, the wind flow is changing. So after simulating this kind of microclimate, and then our planners will decide whether this kind of microclimate changing or wind pattern changing is acceptable or not, and then they will can proceed their development plan. Actually, this is the real case, and then the actually South Korea is a relatively very safe country. However, many citizens still believe that installing a CCTV in front of their house will make them feel safer. So many citizens ask the city hall to install CCTV just in front of their house or just near house. But as you know, budget is limited. So we have to decide which point is very suitable for placing the CCTV. So we developed this CCTV optimization digital twin for the Busan city. And then now you can see the pole, and then now you can see the type of the camera, CCTV cameras. So by simulating the field of view, we can detect which area will be visible and which area will not be visible. Because the building height is the real height, and then now you can see the obstruction areas. So by changing the field of view, camera angles, and then the other headings and other things we can simulate. And also we can change the position of the CCTV. We carry out we can detect which area is visible and which area is not visible in real time. And then we can optimize the CCTV placement with very limited budget. And this is underground geography information management using digital twins. And this is real case from Sejong City where I live. And then now you can see the many pipelines at the underground. And then by clicking the pipeline, we can get the attribute of the pipeline information. At the same time, this is a profiling of the underground facilities. Also, we can carry out a so-called virtual excavation. And by doing that, we can understand the geographical context of the underground pipelines like this. And then by printing out this information, and then our CTO officer can give this layout to the construction workers, and then we can avoid any accidental damage to the underground facilities. And the next phase will be like this. If we utilize the smart glass and the Apple's Vision Pro or Google Glasses, and then if we combine the AR technology, and then we can go to the real field and just turn on the smart glasses, and then we can see the maybe underground facilities at the real point, at the real places in near future, I believe. And the safety management. in South Korea, one of the priorities that to reduce the casualties of the construction workers. So we attached the smart tag to the construction workers wear clothes, and then we can track their locations at real time. So using a beacon and the smart tag, we can keep track of construction workers' real locations. And in case of any construction failure or construction accident, we can easily deploy our emergency team to save their life. This is the more wide area constructions, and then also in this case, this is outdoor space. So we just use the smartphones to keep track of the real locations of the heavy machineries like excavators. Now you can see the real plate number. So now you can see the real location of the excavators. Also, now you can see the real location of the construction workers with their names. Also, all these kind of their moving track is recorded. So by combining that, we can generate the heat map like this. Also, we can identify the moving trajectories of the heavy machineries like excavators like this. So using this kind of data, maybe we can optimize the construction process as well. And this project is for the Ministry of Environment in Korea, and then this project is for the chemical release accident. This city, the name of this city is Dangjin, and then the Dangjin has lots of chemical plants out there, and then the citizens in Dangjin city are very worried about the chemical release accident. Actually, also they already experienced several times that kind of things. So this project has two main purposes. The first one is that we can simulate the possible chemical release accident. And the second one is we can reconstruct the historical chemical accidents using this kind of simulations. So using temperature, humidity, and the wind direction and wind speed, also the released chemical materials, our chemical expert will produce this kind of simulation data, and then we will show that kind of prompts like this, and then we can overlay the location of our citizens, and then how much those was exposed to the citizens. At the bottom side, now you can see that. So by simulating many times, our government can identify which area is very, very dangerous to the citizens' health in case of the chemical release accident, and then they can set up a new emergency plan to mitigate the kind of harmness and other accident. Also, they can reconstruct the historical accident, and then they will have a new plan how to avoid the kind of chemical accident as well. Actually, I believe many of you remember the last summer's tragedy in Spain. Actually, last summer, Valencia in Spain suffered from very heavy rains, and we saw the lots of loss of human lives. So actually, South Korea is also very, very hilly country, so there are many mountain areas. So nowadays, urban flood is one of the key disaster here in Korea because of the climate changing. So now you can see how South Korea government try to protect and mitigate the urban flood. Now you can see the change the return interval of the rainfall and the duration of the rainfall, and then it will simulate how large area will be affected by this kind of precipitation and rainfall. And now you can click the buildings, and we can get the detailed information of that building, the submerged building. Also, this system is linked with the building information systems in Korea, so we can get the very high detailed information from that. Also, this is for the urban landslide. As I already mentioned, there are lots of mountains. So also there are many hills. So many hilly points are designated as a very hazardous point. And then the South Korean government is trying to mitigate any accident around there. So they have to manage this kind of very hazardous areas. So they have to check like this, and then they use the drones and then the other sensors. So this is IR, infrared photos. Also, they can upload the RGB. Also, in case they have the point cloud, they can upload to their own systems. So they can see like this. Also, we can see the point cloud data in this area like this. Also, street view, there is a street view. So by clicking the street view here, we can see the real context of that area like this. Also, this is a GIS system, so we can analyze the potential landslide area. Like we can identify the potential landslide area like this. So this area is not designated, but we can identify that using a geoanalysis. Also, we can overlay the landslide hazardous map, and then also we can overlay the flood map like this. So by combining all of this information, our disaster management officer can make their own emergency acting plan. Also, in real cases, they will send out the text message to the citizens, and then they can easily evacuate our citizens to the safer places. So this is how still it is. So this is we are currently working with the National Disaster Management Institute here in Korea, and then this is a national-wide project. This year is the third year, and then this project covers the whole South Korea, and then we extruded the 22 million old South Korean buildings to these digital twins. Also, we have utilized the 1 meter resolution digital elevation model for the 72 cities, and then also we utilized the 5 meter resolution digital elevation model for the mountainous area. Also, we are using the 25 centimeter also photos for this project. And then nowadays, my company is working together with the Korea Forest Service, and this is a landslide simulation for the Forest Service. This is very similar to the previous project, but the difference is that this is more dynamic. And then this project is for the rural areas, and this project is for the mountainous areas. So now you can see the simulation of the landslide, and then this simulation is produced by experts here in Korea, and now you can see which building is affected by this kind of landslide. And then now also we can simulate the landslide like this, and without the debris barriers, the landslide will hit the buildings and other facilities directly like this. But in case if we build the debris barrier in the middle of the valley, and then we can mitigate the landslide impact of the landslide. Now you will see here. So landslide starts, But in the middle of the valley, there is a debris barrier, and then the landslide flow will be slowed down, and then the affected area will be reduced like this very drastically. So by simulating like this, we can identify the optimized point for the debris barrier buildings. So this is just a new town virtual experiences. Nowadays, the South Korean government is building 6 ambitious new towns to ease the housing problem. Housing problem is the global problem, I believe. Anyway, so South Korean government is building a new, very ambitious 6 new towns like this, and then they opened all their planning to the South Korean citizens. So any of South Korean citizens can visit here, and then they can explore the new towns like this. And then if they are happy with these new towns, they can ask some kind of, they can buy their apartment and other things. By servicing this kind of new town virtual experiences, South Korean government try to build, how I can say that, try to ensure South Korean citizens that they are doing their best to relieve the housing issues here in Korea. And now you can see the joining informations. Also, rail network. So every South Korean citizens can visit this site, and then they can enjoy the virtual experiences. And this is just a toy for my companies. Okay, the last part is lessons learned. So around 2 years ago, Dr. Bin-Yu Ray has published this kind of very nice paper, and then actually she surveyed many things to the digital twin expert, and then she asked what are the technical challenges to implement urban digital twins? What are the non-technical challenges to implement urban digital twins? And then these are the results from her surveys. So in terms of technical challenges, there are data, integration, interoperabilities, and the software, these kind of technical challenges. But as an engineer-based businessman, I believe we can easily solve these kind of technical challenges. But in my opinion, the most important and the very hard to solve problem is the non-technical challenges in terms of understanding and in terms of practical values, in terms of collaborations. Actually, as you saw, my company already implemented many kinds of successful projects. But the problem is that cannot be used in real world, in real government practice because of the regulations and then the legal frameworks and then the lack of understandings and then the practical values and then the communications. So when you meet your client, every client has their own dreams for the digital twins. So they have their own pictures about the digital twins. So it is very hard to persuade them. Also, practical value itself is not so good so far. Many government offices just want a very sci-fi style visualizations or game style visualizations. Yeah. So I believe standard and interoperability should be the key factor for the success of the urban digital twins. Actually, as you know, city itself is very complex system. City itself is very complex systems, and then there are too many domains. So if we twinning the cities to the virtual world, we have to have some kind of tools or communications channels. That is a standard. So without standard, I think it would be impossible to implement urban digital twin successfully. So standard and interoperability are critical factor for the success of the digital twins. And then the digital twins are nowadays termed as a system of systems and federated systems. So, and then all the digital twin is not always the digital twins. This is a lessons from our Dr. Ho-sang Sagong. He was a former general director of the National Geographic Information Institute here in Korea, and he said that there are many digital twins available out there here in Korea, but not always that is the real digital twins because of lack of clear digitalization strategy and unclear purpose and excessive use of 3D and then just focusing on the flash visual effects, and many government just trying to transform the data manually, also just focus on the visual appealing and the standard online systems, absence of open APIs, and the lack of measures to ensure data integrity, and no clear approach for the data processing and analysis. So he said that all the digital twin is not always the digital twins. So wrapping up, this is my last slide. So, however, now I'm seeing the expansion of the digital twins in various fields, not only in the urban areas, but also in the ecosystems and environmental management as well. Also, at the same time, there are huge hurdles in large-scale, real-time data, dynamic data processing and service and visualizations. Also, once again, I would like to stress the importance of the standard. Without standard, we could not communicate. We could not talk to the other domain expert. Also, there are increasing emergence of the Geo AI that understands the language. So now I can see the many tries to integrate the ChatGPT or LLMs to the digital twins. Also, my company is involved in a Geo AI project for the Seoul S-map. So maybe you will see that service at the middle of this year. Actually, I know all of you are expert of the QGIS, all of you are expert of the ArcGIS and other systems, but this actually that is too difficult to use, too complicated. So my mission is quite simple, just typing in your needs to the as a prompt, and then our digital twin should produce the result to the citizens. So that is the Geo AI that understands the language. And then the digital twin itself should deliver practical values for the long-term success. Just for the sci-fi style visualizations and then the visual appealing will not last long, I believe. So there are lots of challenges we have to get over, but there is a long way to go, but we have to go. Thank you so much. Yeah.